So we're in section 5.2, and I'm just going to do that first example. Now, I'm not going to use Kramer's rule, so that's part of the reason for doing the example. So we want to do the typical, say, two equations, two unknowns, except this time everything's complex. This is 2 plus 7i, and then 7z plus 8 minus 2iw is equal to 4 minus 9i. So if we just go through and think of the reduced row echelon stuff, probably since we have a 7 here, I think swapping row 1 and row 2 makes sense to me to do that first. So that's what I'll do. I don't have to, but that way I don't have to divide through by 1 plus I. Okay, so 7z plus 8 minus 2iw is equal to 4 minus 9i, and 1 plus I z plus 2 minus I w is 2 plus 7i. And now I'll divide through. I'll take r1 over 7, and so I get z plus 8 sevenths minus 2 sevenths, 2 sevenths I w equals 4 sevenths minus 9 sevenths I, and 1 plus I z plus 2 minus I w is 2i, 2 plus 7i. Okay, now I'll multiply I'll take row 2 plus, or actually minus, I guess, minus 1 plus I times row 1 and put that back into row 2. So that first row is the same, 7 plus 8 over 7 minus 2 sevenths I w equals 4 sevenths minus 9 over 7i. And now I know I get 0 here. I just realized I'm not sure why I kept the variables and didn't just go to an augmented matrix. I'll do that next. I don't know. Just didn't notice that I hadn't done that. So now, okay, now I have to take that 1 plus I, the negative of that, times this 8 sevenths and so forth. So what I'm going to do is write down here, do my calculations, and then go from there. So I have 1 plus I times 8 sevenths minus 2 sevenths I, and then I'm going to add that to 2 minus I, and so that is, well, 1 through everything, that's just 8 sevenths minus 2 sevenths I, and then plus I times everything, that's 8 sevenths I, and I times I is negative 1, and there's already a negative, so I get plus 2 sevenths, and then plus 2 minus I. So real numbers, I've got 8 sevenths plus 2 sevenths, that is 10 sevenths plus 14 sevenths, That looks to be, what, 24/7? So I'll put that here, 24/7. And then I've got a -2/7 and a +8/7. That's 6/7 I. 6/7 minus 1I, so that's minus I over 7. Okay, so I believe I have that one. Let's see. So actually, I don't know that I have that one. Oh, yeah, okay. So I knew something looked wrong. I forgot my negative. Okay, so that'll be a negative on that. So let me erase that part and get my negative on there. So sorry about that. So that's a negative, that's a positive. That's a negative, and that's a negative. Okay, much better, I think. So we have our -10/7 and 14/7. That's 4/7. And then -6/7 and a -1, that's -13/7 I. Okay, so I think that sounds better. So I can come up here, and again, for now, I'll keep the W in there. So we have plus 4/7 minus 13/7 I times W equals. And I need to do that same sort of thing. I'll remember my negative this time. 1 plus I times 4/7 minus 9/7 I. Yep. Okay. And then, oops, what was down there? 2 plus 7I. So then plus 2 plus 7I. Okay, multiply the 1 through again. I get minus 4/7 because of the negative. I'll get a plus 9/7 I. And then multiplying through by negative I, I get minus 4/7 I. And so a negative and a negative make a positive, but then I times I makes -1, so we get minus 9/7, and that's plus 2 plus 7I. So that ends up being our real numbers. I have a -9 and a -4, so that's -13/7 plus 14/7. That looks like 1/7. And then positive 9, -4, that's 5/7. That's positive 5/7. And 49/7. 49 and 5 is 54, so plus 54 over 7I. Okay, so I have 1/7 plus 54 over 7I. Okay, so I have that. Now what I want to do is divide through by that coefficient. So I'm going to rewrite all this as my augmented matrix first. So I have a 1, a 0, 8/7 minus 2/7 I. Yeah, like I say, I don't know why I kept the variables around. 4/7 minus 13/7 I, and then that's augmented with 4/7 minus 9/7 I, and 1/7 plus 54/7I. Okay, so now I'm going to multiply through by the multiplicative inverse of our number here to get a 1. And so that multiplicative inverse, I'll do my calculations. Remember, the multiplicative inverse is just the conjugate of that thing divided by its magnitude, actually squared. So the real component squared plus the imaginary component squared. So I end up with 16/49 plus 169/49. And so that's the number I'm multiplying by. And what I need to do is multiply this number over here by that number, because I know I get a 1 in the first spot. So I'm going to multiply all this times 1/7 plus 54/7I. So when I do that, this is equal to, well, I have a 4/49 with the 1/7 times the 1/4 times the 4/7, and then the 4/7 times the 54. I believe that is, let's see, 4 times 50 is 200, so I believe that's 216I/49. And then for the 13/7, well, I've got 13 plus 13/7I. And then 13 times 54, and it's going to be a negative because I've got an I times I, so that's -1. And, I should have wrote 49 there. And then 13 times 54, well, 10 times 54 is 540, so I'll make a note of that, 540. 3 times 54 is 150, 162, so this looks like 702, I think, 702/49, and this is all divided by 16, and 169 is 185/49. Now, the nice part is, right, when I invert and multiply, all the 49s go away, and so this is equal to minus 698 over, well, I'll wait to do the over 185, so I'll do that. And then 216 and 13 is 229, so plus 229I over all over 185. Okay, so when I rewrite this, I have 1, 0, 1, and what the heck did we have up there? 8/7 minus 2/7I, and then this is augmented with, well, this bottom part is minus 698 over 185 plus 229I over 185, and the top is what, 4/7 and minus 9/7, so 4/7 minus 9/7I. So that's what we have so far. So I can tell you that W is that number which is what they got in the text, I believe. Let me look at it here. I got to go back and look on my stuff here. Yes, great. That is what they got for W. Now Z, if I want to get Z, well, I need to multiply the bottom row here by the negative of this thing and add that to the top row. So I have minus 8 over 7 plus 2 over 7i times minus 698 over 185 plus 229i over 185. And then I will add to that plus 4/7 minus 9 over 7i. Okay, well, it looks like I need a common denominator. And what, 7 goes into 185, what, 20, oh, does it go into 185? I would think it would. Isn't that where we got the 180? Oh, no, we didn't get the 185 from the, all that stuff, did we? Can I get a common denominator 185? Let's see, 7. See, so, you know, calculation on this stuff's pain, right? So 7 into 185, I go 2, 14, 45. Oh, bummer. That does not go in evenly. Let's see, I don't think I can reduce anything yet, can I? No, I don't think so. So, okay. So I need to multiply the 185 by 7 and the 7s by 185, I guess. Ooh, yuck. So, is this really true? Can I reduce, before this gets out of hand, the question is, I guess I can't reduce the 698 over 185. Wow, this is just starting to get really ugly. So, I guess what I'm going to do is try to do my calculations on decimals, because wow, I just really don't want to do this, right? So I have, let's write out the pieces and then I'll do it on decimals. Yuck. So this is 8 times 698 over 185. And then, oops, times 7. And, oh, does 7 go into 698, I wonder? 7 into 698. I hope so. We'll see. Okay, so I got 7 times 185, and then the other real part is the, minus 2 times 229 over 7 times 185. So there's the other real part from those two. Now the two imaginary pieces, I have a minus 8 times 229 over 7 times 185. Oops, 185 I, and then a minus 2 times 698. Here, I'm going to get rid of that stuff. 2 times 698 over 7 times 185 I. And then I have the plus 4 over 7 minus 9 over 7I. So, okay, so there I can get rid of that. So, okay, the question is, can I get rid of the 7? Does 7 go into 698? Well, 63, and then, so that'll leave us 68. 68? No, because 63 is it. So, no, that still doesn't work. So, yeah, I think I'm going to have to take, you know, this number, that number, and that number. I'm going to go do it on a calculator because, wow, that just doesn't, this does not look like fun. So let's go here, go to Chrome. Hopefully Desmos comes up. Yep. All right, so I need to kind of go back and forth because I don't have this written down anywhere other than here. So 8 times 698. So I realize this is getting long, but hey, you know, let's do it. 8 times, so I've got 8 times 698, and then that's divided by 7 times 185. Okay, so I have that term, and then I have a minus, I think. Is that right? Yes, minus 2 times 229. So minus 2 times 229, and that is also divided by 7 times 185. And then finally, I think it was plus, make sure here, plus 4/7. Okay, so plus 4 divided by 7. And now I'll hit this little fraction thingy, maybe. And that's 838 divided by 185. So that's 838 divided by 185. That's that term. And that is what they got, so good. That's nice. And now I'll do the imaginary parts. And so I have 8 times 229. Okay, so now it is 8 times 229 divided by 7 times 185. And then it was minus 2 times 698 minus 2 times 698, all divided by 7 times 185. And then finally, I think it was a minus, yeah, minus 9/7. So minus 9 divided by 7. And once again, we'll hit fraction. And that says, oh, that's off a little bit somehow, because we have a minus 1229, and it's supposed over 1295. So let's go back and check to make sure I've got the right pieces in here. Okay, so I said, and so we're going to have a minus here, and okay, I said back here, let me look at something on my own stuff here. So I try to reconcile what I might have done. Okay, minus 2 cents. Okay, so I'm good there. Alrighty, so I have my minus 8/7 and plus 2/7. I'm checking here and here. So that looks right. I have minus there, and so then I have a plus here and a minus 2 times 229. I think that looks okay. A minus and a minus. And then for the imaginary, and then the plus 4/7, and then for the imaginary stuff, I have the minus 8 times the 229. Yeah, that looks okay. And the positive 2 times the negative 698, that looks okay. And then a minus 9/7. Okay, so let me go back to Desmos. And I had an 8 times 229. It looks like, oh, I should have a minus 8 times 229. Oops, that's not what I wanted. All right, but that's a minus 8 times 229. And so I'll go in here and put that minus. And there's my minus 699 over 185. So sorry about that, but that's the kind of thing that happens. So minus 699 over 185i. So I get that, and so 1001 838 over 185 minus 699 over 185i, and whatever else I had there, 698 and 229, so minus 698 plus 229i, and these were each over 185. Whew. Okay, so that was, here's our Z, here's our W, and we did get what they got. But so you can do it, reduce row echelon form, but the actual calculations, wow, that is rough. And so we'll do another video where we do it using Sage.